Welcome, everyone. Thank you very much for joining. We are extremely delighted to have you here today. I'm Mac, together with Matt, directors of ECSE and product marketing, joined by Stu and Dale, SAs or SEs from the Americas. But the massively appreciated guest, the big star of the show, is Rasika with us today. And probably everyone knows Rasika. If you don't know Rasika, then Google him and see his blog, CCIE Wireless, Mr. CCIE W, the best blog on the internet to learn Wi-Fi, honestly, like the technical stuff. So Rasika, thank you very much for joining, my friends. How are you doing? Why won't you do a quick introduction?
Yeah, thank you very much. It's a pleasure to be here, at least to share some of the knowledge, as I briefly mentioned, I based in Australia, Melbourne, so I work for a university here as a senior manager for networks and facilities. So look after the wired and wireless infrastructure. Outside of that, actually, I become an instructor. So I normally teach, Ekahau, CWNP, and Cisco specific training. Yeah, that's about me.
It is a massive pleasure to have you, mate. Okay, so let's crack on with today's content. Today's title is called The Lord of the Pings, and we will be talking about the Wi-Fi client discovery. So today it will be a little bit more technical than it typically is, which is probably a good thing for those of us that are interested in more technical, detailed Wi-Fi. Okay, so let's crack on with the content and enjoy.
Yeah, let's go. Actually, so I try to basically, go start this with, what is a 5 gigahertz spectrum, what we're talking about is how client discover the wireless network. To begin with, let's look at this, how the spectrum is basically in the 6 gigahertz, but let's begin with the 5 gigahertz. So as you all know, basically 5 gigahertz, we have a few unit channel, basically Uni 1 to begin with, 4 channels, and then another 100 megahertz Uni 2. And then we have something called Uni 2B, these channel from starting channel number 68 to 100, that's are not allocated for Wi-Fi. In that way, Uni 2B is not for Wi-Fi, but then we have Uni 2C band, so there are 13 channels, 12 channels are there. And then discontinuing actually Uni 3, channel number 149 to 165. And then the last sort of block of channel, actually that's allocated for Wi-Fi starting 2022. So Uni 4, so you will see a lot of latest client actually supporting these 3 channel. So in that way, if you want to have a 80 megahertz channel, actually Uni 3 and Uni 4 can be combined. But there are certain rules, if you want to use Uni 4, those Uni 4 only able to use indoor, and pretty much like integrated antenna kind of deployment. You cannot power it from the battery powered sort of way. Certain power restrictions. So if you're combining Uni 3 and Uni 4, probably you have to go with the lowest common factors, which is Uni 4 capability. That's the one thing to keep in mind. But client support point of view, Uni 4 support may be not there for the legacy client or previous client, but any client certifying nowadays, you can read sort of a specific detail. They're supporting Uni 4 channels. So in summary, actually there are 28 channels in the FCC regulations, but depending on where you are, all of these channels may not be there, keep in mind, but that goes up to the 5.925, a 30 megahertz kind of band gap is there. But so this is for the 5 gigahertz. So now when we looked at 6 gigahertz immediately starting 5.925. So if you look at the 6 gigahertz spectrum, we have a first 500 meg, what we call Uni 5, continuation of those Uni band. That's called Uni 5. You have a 24 channel, but all these channels are basically already used by certain services, fixed microwave link, satellite services. It is not completely free to use. but there are certain sort of regulations are there. So if you want to use, we can use in certain conditions, like that way. Worldwide, these 24 channels has been allocated for Wi-Fi, each regulatories. But when it comes to US, they have already allocated the entire spectrum, that way they have a Uni 6, 600 megahertz kind of spectrum, and then Uni 7 as well, another 350 megahertz spectrum, and then Uni 8, another 250 megahertz. So if you take collectively, that this is total of 1.2 gig kind of spectrum. So when we look at the worldwide spectrum allocation, there are twofold, certain countries, the entire spectrum allocated for Wi-Fi. The countries in the map shown in the green color kind of thing, like North America, South America, South Korea, and Saudi Arabia. Typically, they allocated entire spectrum. But most of the Europe and Australia, New Zealand, those countries actually only allocated the Uni 5. That means the first 500 meg, which give the 24 channels. So because there are so many different sort of uniband, FCC documented, like what is the sort of use case rules where you can use. So that's why I listed this particular, there's something called knowledge database article 987594. If you search that, you will get all the detail. What are the specific guideline? So next, I will talk about certain sort of client devices, those devices type. So that KDB article is the reference for that. So now, as you can see, there are 59 channels available, in that way, that's a big jump, so if I have to discover using standard method, I have to go and basically probing these 59 channels, so which is not ideal. So that's the one thing we're going to look at detail. What are the different mechanisms enabled for discovering those channels in Wi-Fi operation in 6 gigahertz. So in this particular spectrum, I have highlighted certain thing in the black and yellow kind of color. So what we call those as a preferred scanning channel. Keep that name in your mind. So when we scanning the spectrum, we nominated not all 59 channel. There are 15 of them as a preferred scanning channel. In that way, client devices know these are the preferred scanning channel. We have a certain way of deployed. You can use that method as well. So in that way, keep that preferred scanning channel kind of differentiation. Not all channels are preferred scanning channel in the spectrum. So let's look at, what are these device classes? We said there are certain rules, so 6 gigahertz devices, they fall into 3 categories, what we call access point and subordinate device and client devices. So subordinate device is like a extender kind of device, it is not a typical client device, but you can use extender like your Wi-Fi mesh extender. You can use your home coverage extension. So if that is kind of thing, it's connecting to a AP, but it's not typically client device. It is extending to your Wi-Fi to another area inside your home. So now that there are the 2 categories we call normally, the access point fall into 2 categories, one APs, we call only indoor deployment. The other APs we call standard power. You can go with a sort of increased power. Typically use case is to use for the outdoor deployment. So let's look at, when the device certification point of view, there are certain type of access point we call indoor access point. So a specific code is actually 6ID. So that specify indoor access point. So what devices can connect to indoor access point? One type is the extender device, what we call subordinate device. So that is named as a 6PP, and then the third type is what we call indoor client. So indoor client typically can connect either to the indoor AP directly, or it can go via the subordinate node. So you can, indoor client can connect to one of those. And then the fourth type actually what we call dual client. So they can connect to the Indo AP as well as standard Power AP. So that is a sort of client actually need to know a little bit more, because if you connect into an Indo AP, there are certain guidelines. If you need to understand what is the Indo AP's operation. But if we connect to the outdoor AP or standard Power AP, then client need to understand what is the rule for the outdoor or standard power operation. In that way, that client behavior has to basically dual kind of phase. Depending on which AP they connect, they need to follow those rules. So then the fifth type of devices type we call standard power, which is the standard power access point, which we call 6SD. So then to standard power AP, as we discussed, you can connect dual client. The other client type you can connect what we call standard client. So that means that client only can connect to a outdoor AP, standard power AP. So last type, the seventh type we call fixed client. Fixed client means that client is not moving. So it is like a permanent infrastructure. We basically mounting or some sort of way in the outdoor deployment scenario, acting as a client. So they standard power, because it can impacting the some established kind of incumbent 6 GHz deployment. They all need to go through some process called AFC, automated frequency coordination. They cannot straight away go and power up. They have to check what is there any interference to the existing incumbent deployment. And if the AFC says there are no problem, you can basically power up and operate. So this AFC operation is the sort of one, because we want to make sure daily basis, we need to check with that database. So if it is a no problem, we can keep our radios on. But in case if AFC is saying we have a problem, then your radio need to be turned off, not immediately. I think if you get communication daily, at the end of the day, like 00 hours, your radio will be turned off if it is interfering. So that is just one thing to keep in mind, the standard power operation driven by AFC. In that way, those access point client devices, especially that fixed client, has to go through the AFC kind of rule. So now, if we look at these 7 type of devices, which particular uniband they can operate, that's another thing to remember. So the Indo deployment, those particular things can occupy any of the uniband. In US, you can use any frequency, but rest of the world, only first 24 channel. We can use that 24 channel for the LPI deployment, that low power Indo deployment. So when it comes to the standard power, they only allowed Uni 5 and Uni 7 band. So in that way, standard power access point can operate on those channels. So now keep that in mind. This is an important slide, because client devices point of view, sometimes you don't know what is your client capability. But we all know is actually going forward, if you're deploying standard power access point, we don't want our client to not connecting, we want our client to connect to the standard power access point as well. In that way, there are 2 categories of client, what we call 6CD and 6XD. So 6XD is the Indo client. They can only connect to an Indo AP. 6CD means it's a dual client. You can connect both world. In that way, the preference is our client fall into 6CD category, where that client can connect either world, like a standard power AP or Indo access point. In that way, keep that mind on those particular 2 categories, 6SD, 6DD, 6CD, because we will look at some client capabilities in next few slides as a reference. But you need to check with your client before deploying 6 GHz, where your client fall into in this particular list. So now this is example showing some Google 6 GHz supported devices point of view. As you can see, like a Pixel 6 is the first end device supporting 6 GHz in the Google sort of phone point of view. Pixel 6, Pixel 7, they're all 6XD. That means they are only Indo client. they can only connect to a indoor access point, 6 gigahertz. But starting from Pixel 8, they basically, you can see it is 6 CD. That means that Pixel 8 phone can connect to a standard power access point as well as low power indoor access point. So it is important to know because in that way, basically Google Pixel 8 will not have problem. But if you're deploying a standard power access point, you have a legacy client, Pixel 6, they may not able to sometimes see USSID, not able to connect in that sense. And if you look at the Apple as well, I think Apple starting supporting 6 gigahertz recently. So then their iPads, like iPhone 15 started supporting 6 gigahertz. They also basically, if you look at the FCC website, go by the sort of I think Apple, it is relatively easy to find out. Their product number basically is closely matched with the FCC ID. In that way, you can easily map. I have shown here some example. So they are basically, you can see Apple devices point of view. All new basically Apple devices 6 CD. That means they are dual client. The only client actually 6 XD is the MacBook M2, which came the first gigahertz capable sort of devices maybe last year or early this year. They are indoor client. They are not able to connect to the outdoor or standard power access point. But other than that, yeah.
So Rasika, I have an iPhone 15 here, and I actually also happen to have one of these MacBook Pro M2s as well. The one that you were just highlighting there as a 6XD. So the next time I see you, it's probably going to be in the US early next year. I would imagine if they somehow were to have some 6 gigahertz standard power outdoor access points, and we was be sitting outside enjoying a nice coffee, and I sat down with my Mac and my iPhone, and they had a 6 gigahertz access point out there with an SSID, my iPhone 15 would be able to see it and connect to it, right? But my Mac wouldn't be able to connect to it because it's the low power indoor device. So that might get a bit confusing for the typical everyday user, right? Thinking, hold on a second, I bought my 6 gigahertz capable Mac back in 2020, early 23 or late 22, and I've got my 6 gigahertz iPhone. Why can't I connect to these different access points when I'm either indoors or outdoors?
Yeah, that's exactly right. In that way, that's the one thing we need to be mindful, in that way. Sometime vendor may basically go back and start supporting, because the hardware is supporting. Sometime by firmware, they should be able to make that, but their product need to be get certified again, for that particular capability. In that way, we will wait and see how it's going to be, but at least you can see the trend now, like a lot of latest client, they're starting supporting dual client. In that way, that is going to be the most popular kind of client type, but you may have some client fall into that particular early stage of the 6 gigahertz client, maybe the only indoor client. So now,
yeah, very interesting for sure. Definitely, Rasika. Thank you for sharing that. That's going to be very useful for people to know, because I can so imagine being confused in that situation. Like, why does one device connect and the other one doesn't at all?
Yeah. So the Samsung point of view, I think they're the one started first 6 gigahertz supported client. In that way, you can see their list is long, but again, from their list as well, starting Galaxy Tab S9 or Samsung Galaxy S23, that onward, they're all supporting 6 SCD kind of category, which is the dual client. But early generation of client, they are basically indoor low power 6 XD. So Intel, on the other hand, all these AX210, 211, even AX411, they are low power indoor client, but starting BE200, which is the first sort of chip supporting Wi-Fi 7 going to be, supported. So they are basically 6 CD. That means they are dual client, in that way, Windows point of view, I think most of them are basically the AX chipset, they still indoor low power, not capable of, or should not basically capable of connecting to a standard power access point. In that way, I have listed here like a few examples, not an extensive list, but the FCC website is the website you should basically go and check. But I think any 6 GHz client devices, FCC wanted to user should be able to verify what is the FCC ID. In that way, the display or basically in the phone display, you can go through the step about the phone and get the regulatory information. Even the packaging, they should list the FCC ID. Why it is really important? Because 6 GHz have so much of impact of the way you deploy can impacting the existing kind of 6 GHz deployment. In that way, you need to be very carefully check those certification details. So now what we are going to do is actually now we understand some sort of 6 GHz client capabilities, but now we will discuss how a client basically discover AP or SSID, they come into a environment. Again, with this one, we will basically look at what's the legacy. That means 2.45 gigahertz, what's happening, in that way. So in that particular world, we can discover either using a passive scanning, what we call normally client discovering SSID using beacon frame, or they can go ahead and do probing, like what we call active scanning. So these are the two common methods. But when we're doing the active scanning, so sometimes client basically do null probes. That means they will not specify the SSID. They're just sending a probe request without specifying SSID, expecting AP responding with all the detail of their SSIDs. So if normally client want to connect to a particular SSID, at that particular time, they can send a directed probe telling that I want to connect to this SSID. Both allowed, both being used. Then when you sending a probe request by client, AP is supposed to respond unicast. That means if 1,000 probe requests, AP has to respond 1,000 probe responses. This is one of the drawback in the current system. AP has a lot of burden responding to these probe requests. And then now, if we look at the 6 gigahertz, there are certain rules. This is the one important thing to get some familiarity. So what is allowed, what is not allowed, in 6 gigahertz. So now the first thing is actually, if you look at, null probes are not permitted. That means client cannot basically sending a probe request, keeping the SSID field blank. So now in the slide, why I'm showing here, because, sometime you will see when you send a probe request in 6 gigahertz, you will see the SSID field name as a number 80. Sometime very first time you may confusing as well. What is number 80? I don't have SSID called number 80. So why that's happening? Because in the standard point of view, they said basically so if you don't know the SSIDs you are probing for, so you cannot really put this field blank. So you can put that value 128, the octet value 128 in hexadecimal, it will become 80. In that way, in that scenario, you still have to basically, if you don't know the SSID, still you have to put this particular value. But there's a concept called short SSID in Wi-Fi 6. That's an important thing. I didn't have a separate slide for it, but always we use a hash value or like a 32-bit CRC. In that way, a lot of communication, we including something called short SSID value, a 32-bit of the hash function. So in that way, this is the hash function of a given SSID. Everybody can calculate. So if this is client sending the probe with this one, if my AP configured for this SSID, AP also has this hash value. In that way, AP can responding, hey, client is asking this SSID. Even this short SSID field is not there. If it is a sort of a probe request, AP should not respond because AP is not responding for the null probe kind of thing. So that is the first thing to remember. Null probe is not permitted. So even you see this value 80, don't get confused. That is per the standard, what you should do. And then the other rule is actually if a client seeing a probe request or probe response or beacon for a particular SSID, then client should not sending a probe for that SSID. That's another rule to preventing probe requests, discouraging the probes in 6 gigahertz. Third rule is actually you cannot immediately probe. You have to wait for a timer called probe delay timer. So typically 20 millisecond kind of thing. You will see why 20 millisecond when we discuss about some in-band discovery. So we are preventing client come and immediately probing. Client will wait for amount of time. More likely within that amount of time, you will see the probe response or beacon or something, some discovery mechanism. And then client can use that rather than probing. So now the last thing is to know is actually AP will responding probe responses, not unicast. They will send in the probe response in the broadcast fashion. So in that way, even one client probe, response will go to broadcast. Everybody in the cell know about the SSID using that probe response because it goes to the broadcast address. So in that way, these are some rules, like a probing perspective. Some of them basically keep some idea, may be helpful. So now let's look at basically in sort of high level, what are the mechanisms available? So now we call one method called, like what we call reduced neighbor report, or sometimes we call out of band discovery. The idea is actually we don't use 6 gigahertz to discover. We're using legacy 2.45 gigahertz to discover 6 gigahertz SSID. So that's make 6 gigahertz clean. We don't want to exchange too many management frame. We discover using the legacy band, which is already available. So in that way, if your AP has a legacy band enable, you can use that to discover the 6 gigahertz SSID. There's a feature called multiple BSSID as well. I will explaining what is that. Can be used, advertising multiple SSID capability in a single beacon frame. In that way, multiple BSSID also can be used to discover the SSIDs. So these are the sort of more main common method you will see. Everybody basically supporting this reduced neighbor report out of band method. So you will see this is the de facto kind of discovery mechanism. But in the worst case,
right, Rasika, some vendors like Apple, they support just the RNR and nothing else.
That's right. I think what I heard was the latest update as they supporting other method as well, but I haven't really tested in detail, really? Maybe the latest version of the iOS, 17 or whatever it is, probably we need to check and see. They may supporting. I haven't really tested well,
Challenge accepted. Let's test it out.
Yeah. So now that is basically if you have a legacy band enable, which is the case 99%9, we are not disabling 2.45. In that way, we can use those methods. But some corner cases, if you really want to 6 gigahertz only deployment, you want to shut down 2.45 gigahertz, then how can client discover? So that's what we call in-band discovery method. So in that way, this is only applicable, but we call sometimes 6 gigahertz only access point. If you're deploying in that fashion, you have to use one of these methods. So we briefly discussed that preferred scanning channel. We can let client to probe and request response and discover. Two additional methods introduced, what we call FILS frame, FILS, fast initial link setup. Concept is to basically, addition to the beacon, you're transmitting some discovery frame very frequently. In that way, client can discover using those frequent frames. Those go in 20 milliseconds. That's what the 20 millisecond probe delay time come into play. They're sending in 20 milliseconds. The other method called unsolicited probe responses. In the legacy world, AP cannot send a probe response without a probe request. But in 6 gigahertz, we said, why not AP unsolicitedly without probe request? Why can't AP send probe responses every 20 millisecond kind of interval? So we can do that. It will be good in books, but in certain way, but because probe responses are almost like a beacon frame. So do you like to send beacon frame every 20 millisecond? Maybe not. In that way, keep in mind this method. That's why we highlight in the red color. Sometime, technically it is there, but you will not see create use unless those corner cases of 6 gigahertz only deployment, or some vendors may not supporting at all UPR. In that way, keep this high level picture in your mind. So now let's look at what is this multiple BSSID. What's the difference between legacy versus 6 gigahertz? So in today, if you're deploying an access point and creating SSID, that will start beaconing every 100 millisecond roughly. If you have a second SSID, AP has to advertise second beacon. So now your beacon overhead will be keep increasing. So if you have a 5-6 SSID, your management overhead will basically too high. That's why we always encouraging, hey, go reduce number of SSIDs. Don't encourage to create more SSIDs because it will increase the management overhead. But in 6 GHz, they address this problem. If you deploy multiple SSID, we are not transmitting multiple beacon frames. We are advertising one beacon frame, but within that beacon frame, we including something called multiple BSSID element. So which is basically advertising other SSID capabilities. In that way, single beacon frame, advertising 6 SSIDs in my example, but this is all 6 GHz client or even 11AX client should understand this element. In that way, even the legacy band, if you can do this, that will basically reducing, some kind of overhead, but definitely 6 GHz. This is the sort of way beaconing works. So you can have a multiple SSID, but using this MBSSID element, client can discover other SSIDs configured in that access point. So this example showing in a sort of a beacon frame that support multiple BSSID. You can see here, that is something called multiple BSSID element, and the SSID beaconing, we call it is a transmitted BSSID or reference BSSID. In that way, one SSID will be the beaconing. Other SSIDs basically listed inside that. So in that way, we will have SSID name and other detail. You can see here, what other SSIDs, then client can discover, look at this element, what other 6 GHz SSIDs configured in the environment. In that way, sometimes this can be used in band, this can be used out of band. This is a common feature. Every 6 GHz station supporting it, not only 6 GHz station, all HE station, that means 11AX client should support this element. In that way, use case can be, it's really useful if client can use that. The only disadvantage is your beacon frame size will be now large because, we have a many information element there. So beacon frame size can be increased. So you can see here, beacon size here is a 1047 byte. Typically it is not the size of a beacon frame. Okay, so let's look at the sort of a reduced neighbor report. This is the sort of method we said every client will be supporting it. So how it works is basically client basically probing, but they are probing on the 5 GHz. When they're sending a probe request, probe response, but in that probe response, you including a element called RNR element, reduced neighbor report element, providing detail about all 6 GHz AP, 6 GHz SSIDs. So that way, advantage actually legacy discovery mechanism already in play. Client can discover the SSIDs using that. In that way, discovery is faster. That way, roaming is efficient. You will discover the neighboring APs in time. In that way, this is the overall most effective method. You should basically see in operation, most of the deployment. So this is example of that kind of capture, you can see in this particular case, I'm showing here is a beacon frame of a channel 165, which is a 5 GHz beacon frame. Inside that beacon frame, you have a reduced neighbor report, RNR element. If you're expanding that, you can see all these additional SSID detail. So now, as I said, you will not directly advertising SSID name. We basically using the short SSID kind of field, which is the hash value. Okay, in that way, example is my client device is configured for this SSID. Then my client already have this hash value. In that way, he know the AP advertising this beacon already supporting my SSID. So because hash function is one-way function, you cannot really easily reverse engineer. That means if I know this value, I cannot tell it is this. But if you know this is the value, I can find it out what is the hash function. This particular short SSID can be calculated easily. So in that way, that's how it being advertised. So now in that way, in summary, I think probably, okay, so before go to summary, I think probably there are another sort of use case of the RNR. The previous example we looked, it's a co-located AP. That means my AP have a 6 GHz SSID, 5 GHz SSID, so in the same AP. But this RNR function can be used even scenario where not co-located SSIDs as well. So how it works in this particular scenario as well, same concept. You will probing the 5 GHz, but when the probe responses come, it will including all neighbor APs which supporting 6 GHz SSID with the channel numbers, and in that way client can discover the neighborhood as well. So in that way, that's depending on the vendor implementation, whether you want to support this, you can see, good use cases. So in this particular example here, actually AP is probing. In this particular case, it is a 6 GHz kind of beaconing. So channel number 5 is basically beaconing, but when he's beacon, he's including RNR element, and he's telling client, hey, there's another access point on channel number 117. In that way, providing that neighborhood detail of other 6 GHz BSSIDs available, then client can go and probe and connect. In that way, this RNR, overall, so the preferred method, because every client supporting it, your vendors should implement this method. I have seen every AP vendors implemented this. So this is sort of a method we will see. I think to now take into summary, so the RNR or out of band discovery is the method you should use, which will provide the faster discovery because client can discover using the legacy band, and roaming improved because improved mean your faster discovery in the legacy band, no dependence on 6 GHz discovery. So this is the method we will see. I think the probably sort of a key takeaway. If you want to know the sort of what we should use, RNR, in that way, keep that in mind. I think probably. So this poll, Mac, are we basically doing some kind of polling question, or basically is that we need to give time to the poll, or?
Yeah, let's launch the question. So we have a very quick question today. What are the most common Wi-Fi troubleshooting tickets? Dead zones in coverage, applications not working right, specific devices not connecting, sudden disconnects from roaming issues, slow upload or download speeds. We are lacking all the above.
Yeah, we'll see. I think that's the easy answer. If that is.
You manage a very large network, right? As well, a big university. I guess you must get quite a lot of trouble tickets raised fairly often, right?
Yeah, so mostly, like in the university environment, what we get is, as example, client connectivity issues, in that way. So roaming sometime, unless it is we don't have a voice over IP, that kind of real-time services. So because we don't have that kind of thing, we don't get, hey, I had a problem like that. But in my case, basically we see typically client connectivity issues,
I think
Let's see what the.
Yeah, I think this is probably one of the closest splits for answers in the poll we've ever had, really. To see such a fairly even spread between the answers. So
crazy, and people asking for more options. User errors, problematic devices. Agree with all of that.
Layer 8 issue.
Yeah. The biggest problem is the thing between a monitor and a chair, which is ours.
All right. Perfect. Thank you very much, everybody.
Yeah, no problem.
Carry on with the webinar.
Yeah, so now what we are going to do is actually now we are going to move on to the other discovery mechanisms. But keep in mind, this will only come into play if you have a 6 GHz only. You want to let your client to discover using 6 GHz band. May not be the case in the production deployment most scenarios, but you can fall into a requirement of that. In that way, just let's look at what are those in-band discovery mechanism client can discover 6 GHz AP using 6 GHz. So first one we call preferred scanning channel, same like legacy client. If probe request, probe responses, you can discover, but we specify that 15 channel, not all 59. In that way, if you deployed 80 megahertz, you can use that. Okay, in that way we'll look at that. And the other method is we call fast initial link setup. FILS, probably remember the name. This is another sort of discovery, passive discovery mechanism you can use. And then the last one is called UPR, unsolicited probe responses. You will see why we highlighted in a bit of red color, because it is adding additional management overhead. That's why we just basically highlighting in red, saying that it is not preferred. But let's look at the technicality of these three methods. So now in the preferred scanning channel, we said basically, if you look at the spectrum, we group into 80 megahertz kind of block. And in each 80 megahertz, the second 20 megahertz, we nominated as a preferred scanning channel. Why second 20 megahertz? Why not first? Now, if you remember, pay attention previously when we said 5 gigahertz finishing, not exactly 5925, 5895. So have a gap of 30 megahertz. But if you basically starting this as the preferred scanning channel, there could be potentially we can interfere with the last channel of the 5 gigahertz. That's why they shifted this to 20 megahertz to make it like a no impact to the 5 gigahertz one. So we shifting the preferred scanning channel to the second channel. So that way, so now idea is client, everybody knows these are the preferred scanning channel. If a client come into the 6 gigahertz world, they can start probing, but they probing start with channel 5, channel 21, channel 37, channel 53, channel 69. It goes like that. So if your deployment is 80 megahertz, so then by scanning channel 5, you can discover that 80 megahertz. If you are in this 80 megahertz, you discover sending that probe into channel 21. So now this will work if you have the 80 megahertz deployment. That is a sort of a catch, if you have the, we said basically in Europe and even Australia, New Zealand, we have the only first 24 channel. So then if I go with the 80 megahertz deployment, I have a 6 channel to work with. Sometimes 6 channel is good enough, but we all know we want more spectrum channel because we have more than 6 APs in the neighborhood. If that is the case, basically you will see, we will basically go with a 40 megahertz deployment. So if you go with 40 megahertz deployment, you can see, first 40 megahertz, I have a PSC, but second 40 megahertz, I don't have a PSC. In that way, if client using PSC method, he will not discover this 40 megahertz. In that way, whenever client roam, they don't discover this AP in the PSC method, that will be problematic. In that way, this will creating some kind of challenges in the other regulatory. In US, you will see this is used, but other regulatories, if you're deploying 80 megahertz, you can use that. But if not, you have to rely on other methods. In that way, preferred scanning channel, is not the sort of it will not work universally if you have anything other than 80 megahertz deployment. Okay, keep that in mind. So now what are the other method available if you want to discover? So we said fields. So let's get a quick understanding about what is fields. So if a client connecting, they will go through a process, discovery process, and then association process, and then getting IP addressing. So that way, normally in the legacy world, beaconing and probe request response, passive scanning, active scanning, we discover. And then once discover, you authenticate and associate and derive the keys. That is another process. And then get in the DORA process, discovery of a request acknowledgement. So this is the initial setup. Initial client connection goes through these frame exchanges. Now the fields look at how to improve time taken for each and every sort of these 3 phases. Okay. In that way, the mechanism called 11 AI amendment came. So fast initial link setup, add mechanism to reduce this time. So now if you think about a sort of a environment like this, very busy environment, So if a client waiting for beacon frame to come to discover, so sometime, sometime people come to station and jump into the train is moving fast. So it doesn't give the client to even discover the SSIDs, they keep moving, so in that kind of scenario, they said basically, why not advertising some small frame, what we call fills discovery frame, every 20 milliseconds. So in that way, idea is if client can use in this fills discovery frame, they can discover the SSIDs rather waiting for the beacon frame. So the thing is basically now we said basically initially, if you remember, 6 GHz client is not allowed to probe immediately. So we need to wait this probe delay time to expire. So then most likely the fills frame come within 20 milliseconds, he will discover. So that way he will not need to request to send a probe request, So idea is actually fills is good because, it's had good intention, but the only thing is actually we are sending additional management frame, what we call fills discovery frame. So this fills discovery frame is every 20 milliseconds. That increase the management overhead little bit. That's the only disadvantage. So what is in this fills discovery frame? If you look at the sort of frame capture, so that has a sort of a basic detail, where client to, what SSID is about, short SSID field will be listed and giving the channel detail and all this particular detail. So then client can actively probe and connect. So you can see the frame capture, beacon frames comes every 100 milliseconds. In between 20 milliseconds, you will see the fills discovery frame. So those frames, small in size, 89 byte in my example, but if you aggregating all together, it's almost like a 1 beacon frame within that interval, because we are sending every 20 milliseconds. In that way, a little bit of overhead, but you can use this particular feature to let client to discover secret SSIDs. So this is the second method. Now PSC and fills, fills discovery is the second method introduced. And the last method of this discovery, we call UPR. UPR mean AP can unsolicitedly send the probe responses. No probe request required, he can send the probe responses. But when he send the probe response almost like a beacon frame. In that way, effectively what we are saying is we are sending beacon almost every 20 milliseconds. In that way, management overhead is too much in this particular method. In that way, this is the least preferred method of discovery, but a standard point of view, this method is available. So just to show the sort of packet capture of that kind of method, you can see my beacon frame is a 335 byte. Probe response is also 329 byte, very similar to the beacon frame. In that way, effectively, we are saying beacon sending every 20 millisecond kind of thing. Management overhead will be very much. In that way, we are not preferred that method, but technically you can use this method. I think that will basically summarize, all this particular discovery method. So to last sort of slide in this particular in-band discovery method. So we have a preferred scanning channel option, but 2040 megahertz in Europe or other regulatories can become a challenging using that method. Fills additional overhead, but your client need to support fills discovery mechanism. Most 6 GHz client nowadays support it. I have tested with Google phone, it's supported. But again, whether all other clients supporting it or not, probably need to be tested. Unsolicited probe responses, least preferred because it's too much of overhead. Beacon kind of information or airtime will be used for probe responses. In that way, I don't think that will be having many users, many use cases. So I think that pretty much summarized the sort of a theoretical sort of part. Probably I'll let Matt or Mac basically, take it further.
Yeah, Rasika, such a smashing content, man. It's like you smashed it completely. So when you have a high retention on a webinar and low chat activity, it means that everyone is dead focused on the content, and the content was amazing. So thank you very much. We've learned a lot today. So now let's go and check the questions. We have a few questions, all of them very good. So guys, if you have any more questions that you would like to have answered, please post them in Q&A, upvote them, and we will try to answer them live as we can. So first question from the first topic, is it possible or expected that 6XD clients will be retested for 6CD compatibility, or is it likely a chipset limitation?
I think it is possible because I have seen, like once you're certifying your product, you can basically get recertified kind of thing from the FCC point of view, like that way you have to make sure your either firmware or something need to be updated and tell basically now client understanding these standard power operation, in that way, if they can prove that their client devices can be tested and this with a particular firmware version, I'm sure it is doable like that, that way. If you go to the FCC certification, you will see so many iterations, like that way, particular client version come 2020, but retested, updated their product. I'm sure it's doable. But whether client vendor go and do this particular thing for all the client they release, that's wait and see. But I'm sure it is doable,
Okay, so we have a follow-up question to this one, which is probably quite relevant to ask now. Considering the 6CD and XD types, is there any compatibility considerations for wireless backhauling?
So wireless backhauling, like if it is a outdoor, definitely then both AP need to be, one particular type, You cannot have one indoor AP and connecting a standard power kind of. I don't think, that will work like that, that way, as long as you have a same standard power, you can have a standard power to backhaul, both need to be standard power,
Of course. Okay.
Sorry, I was going to say, well, since Rasika during the webinar showed lots of slides that included looking at going through frames in a protocol analyzer, we thought it would be great to end the webinar by showing you just how easy it can be to do a wireless packet capture using your Ekahau applications and the Ekahau Sidekick 2 to actually be able to capture those wireless packets and then analyze them in your favorite protocol analyzer, since it's very easy now to be able to capture on 6 GHz channels as well using the Sidekick 2. So we've recently launched it. If you've got access to our analyzer application, you can actually use this feature as of right now. And if you head to the next slide, please, Rasika. Thank you. The reason why it's so easy to capture packets on multiple channels at the same time on 6 GHz is because inside of the Sidekick 2, we actually have 4 Wi-Fi radios that are capable of listening on 6 GHz. So that means that we can actually set those radios to listen and capture those wireless packets over the air on 6 GHz. So the next slide, please, Rasika. There'll be many different reasons as to why you would want to do a packet capture to do some protocol analysis. It can be if you need to do some kind of deep troubleshooting analysis, or if you're a big Wi-Fi nerd and geek like most of us here on the webinar today, like Rasika, and you really want to dive into the protocol and take a look at the deep dive into that information so you can actually see all of those amazing things that Rasika was showing us earlier inside of your favorite protocol analyzer. So really handy, easy way of being able to do that now. And I thought what would be nice to show you is actually a quick demo of doing a packet capture using the analyzer app and Sidekick 2. So let me just prepare that for everybody. So what I've got here, if I just open it, you'll see I've actually got my iPhone 15 directly connected to the Sidekick 2, and you'll notice that we have a few options that we have here. We can actually capture all of the 6 GHz channels, so not just the PSC channels, and also a feature coming very soon, we'll be able to do a full frame capture as well. So I wanted to do have both those options. So I simply just enabled them both. And then what I need to do is I actually need to check to see in my environment, and sorry about this, everybody, we're gonna have to turn our heads to take a look at this for a moment. I wanted to check to see what channels my access points in my environment on 6 GHz were using, so I could then set my capture to be on those 2 channels. So I got 2 6 GHz access points. One was using channel 5 and the other one using channel 69. So after I check that in the analyzer application, what I do is I simply click on packet capture, and it's going to launch it, and I will just press start capture, and then I can scroll down to the 6 gigahertz and I select channel 5 and then channel 9, and then I simply just hit capture. So the packet capture is going to start initializing, and then it's just running. So what I also did in the background was I disconnected my iPad, which is also 6 gigahertz, from the Wi-Fi, and then I reconnected it to my Wi-Fi network, to the 6 gigahertz SSID. So what we can do is, once I finish the packet capture, I can actually open the packet capture in Wireshark and show you that process. And it was super easy for me to do. I just hit share and I share it to my MacBook, and just like that, the file has been shared of the packet capture. So if I now share my screen, I can actually quickly show you this. 1 second. So what I really like about when you do a packet capture with the Sidekick 2 is the naming convention that it gives it. Really easy to see, you know, the date of when I did the packet capture, 16th of November 2023, the time. I used the Sidekick 2, but also you can notice here that it actually has the channels that I did the packet capture on as well. So if you're doing any kind of like protocol analysis, this makes it very easy to kind of go through multiple different captures and analyze them. So what I've got here very quickly is you can see that I've got a broadcast happening right now from one of my access points, which is the beacon frame broadcasting on channel 69, the Ekahau 6 gigahertz SSID. But if we look at a couple of frames down, you can see my iPad Pro 6 gigahertz also sending a broadcast, which Rasika was talking about earlier, management type frame, with a probe request, which was actually sent out on channel 5. And I was actually looking for that 6 gigahertz SSID. Well, my access point that was working on channel 5, it heard the probe request and it sent back a probe response on the channel for that. And then if we scroll down a little bit, we can see that my client device, iPad, and access point starts to go through that open system authentication that Rasika was showing us earlier, where we go through our authentication request, authentication response. And once we've gone through that process, we then start our association request, association response between the client of a 6 gigahertz client device and access point. And then once we've gone through the open system authentication, that's when we can start to go through that 4-way handshake, because I've got some authentication and encryption set up on my SSID. And that's where we go through, you see these key messages here, 1 of 4. So that's the start of the 4-way handshake. So message 1, 2, 3, and 4. So super simple to do, really easy to do a capture on 6 gigahertz, share it to your device, and then open it on your favorite protocol analyzer. So yeah. Oh, I've been signed out of my slides, but that's pretty much it.